Alright, what do you think? You think there's fecal bacteria in here with these turtles? So let's get our sample. Without getting bit. We're going to see if you're swimming in your own feces. To test this water sample we just got from the turtle tank, I'm going to do several tests. The first is the presumptive test using lactose fermentation tubes. I have to put 10 milliliters of water into each of these. I have to put 1 milliliter into each of these and 0.1 into these. So how are we going to do that? Well, we're going to use these. These are micro pipetters. Well, they only go from 1 to 5 milliliters, and then they go smaller, and we need 10. So I'm going to set this to 5.0. There you go, you just turn the handle, and now we need a sterile tip. So these have been sterilized. You jab it on there like that, and now you press this down, keep holding it down, open your water sample, stick the tip in, and let go. And it sucks up 5 milliliters. So we're going to put 5 in here, but we need another 5. So now press down on the green handle, hold it in the water, let go. Okay. Okay. So now we have 10. Okay, when it comes to the 1 milliliter, we can turn this back down to 1. Alright, 1.00. Press down, hold it, suck up 1 milliliter, and put it in here. And I'll repeat that with all of these tubes. I'll show you this in just a minute. So these tubes are going to get 0.1 milliliters, so we have to use a different pipette. This one goes from 20 to 200 microliters. Well, 100 microliters is 0.1 milliliter, so let's change this to 100. And these are very small quantities. Less than a milliliter is a very small amount. Okay, 98, 99, 100. Now we use a small tip and press the yellow handle down, hold it in here, and just that little tiny amount is 0.1 milliliters. So press down, repeat with the other 2. I wish y'all could do this, it's fun. Science. Okay. And 1 more. Okay, now what I forgot to show you before is that to get rid of this tip, normally I'd have a beaker, but I've got biohazard because we don't know what was in that water. To get rid of the tip, you press this part all the way down and it ejects the tip. So you never come in contact with the sample. Okay, to test for fecal coliforms, I'm going to pour this Petri plate. This is McConkey agar. This will turn bright pink if fecal coliform bacteria grow on McConkey agar. Okay, now that our McConkey agar has solidified, I'm going to put a streak of the water sample on one side. I'll show you that in a minute. But we're going to compare it to something we know will be positive for fecal coliforms, and that's E. coli. So I'm going to have E. coli on this side and the water sample on this side, and we're going to see if the water sample changes color in the same way that the E. coli changes color. So flip our Petri plate over, start our Bunsen burner, simply sterilize your transfer loop. Okay, let it cool. I'm going to get a droplet of the turtle tank water. Okay, and I'm going to spread it where we have H2O. Just gently, and then sterilize. Okay. And now I'm going to repeat with the E. coli. Okay, E. coli's on this side. Alright, that's all it takes. Sterilize. And now the Petri plate and these test tubes go in the incubator. We'll look at the results tomorrow. Alright, you remember our fermentation tubes that started red, and if they change to yellow colored tubes, are positive for lactose fermentation. We have our 3 sets of 10 milliliters of water, 3 sets of 1 milliliter water, 3 sets of 0.1 milliliter water, and look, this is really easy. All 3 of those are yellow with little gas bubbles. So how many were positive? 3. Same goes for the next set. 3. And the last set, all 3. Okay, now what we want to do is use the most probable number table to estimate how many bacteria were in the original water sample. So most probable number table is an estimate based on basically a standard curve where they've done these experiments and they can predict how many bacteria based on how many tubes change color. We had 3, 3, 3. So we go down here and it's all the way at the end. We have over 1,100 bacteria in 100 milliliters of water, and that is crazy. I would not want to drink that, but we want to know whether these are fecal coliforms. Now, fecal coliforms are gram-negative bacteria that ferment lactose and produce acid. Okay, so we need to do a gram stain, but also we can skip ahead before we do our gram stain. Let's look at our MacConkey agar Petri plate. You see here, MacConkey agar will turn pink in the presence of fecal coliforms. On the left, these are bacteria that are not fecal coliforms. Let's look at our Petri plate. E. coli, not a surprise, was fecal coliforms. Our water sample is also pink. You just can't really see it because it's growing so close to E. coli. Both of these are pink, and so MacConkey agar results positive for fecal coliforms. That's a pink reaction on MacConkey agar. So yes, the water sample had fecal coliforms. You'll notice this is an easy confirmation test. Okay, now let's go back. If we want to do a confirmation using lactose tubes, remember the definition for fecal coliforms: gram-negative bacteria that ferment lactose. Okay, they're rod-shaped, they don't have endospores. Well, all we showed with this test is that they fermented lactose. So that's why it's called the presumptive test, because presumably, if they digest lactose, they could be fecal coliforms. So let's go ahead and do a gram stain and see if we have gram-negative rod-shaped bacteria. Here they are, gram-negative rods, no endospores. These are fecal coliforms.